Some negative aspects of the Docker local implementation is there's actually a single point of failure, meaning that if the container had gone down, it would not be able to be brought back up with the current working state. And this could lead to you actually losing your entire WordPress blog wiki page and all the work associated with it. Also, you have to understand networking in great depth in order to even get this Docker container-based implementation running. Also, there's the possibility of latency and other failures due to the fact of too many people connecting to the WordPress blog locally. Now, with the gcloud Kubernetes, you have to pay for the service, which is definitely a negative, and it can be quite costly over the span of a year. Also, it can be very hard to figure out how to create a project if you specify the parameters as in the documentation provided through Google. And also, it requires you to specify a compute zone that is most suitable and most effective for you. Also, it can take some time to learn, so there's definitely a learning curve in terms of Kubernetes. Also, there's the issue of who owns the data in terms of data governance. Now, with the local Kubernetes, it's hard to understand the networking. There's definitely much more of a learning curve. Also, you're limited to 50 pods, in which I actually spent an hour and a half waiting for all the pods to download and spin up, which they never did, and also there was never a warning message. Also, some of the command parameters are missing from the older kube control, and also scaling at large is hard. There is also only a local internal network for communication between the cluster, which is definitely a negative. And also there's the possibility for latency as well as failures. Now, if you were to start out, I would say definitely do the local Kubernetes implementation first, so this way when you get into the gcloud Kubernetes, you'll have a much easier time in terms of troubleshooting possible issues that arise, and you'll have a deeper understanding of the networking concepts that are being applied inside gcloud. So in terms of the future Kubernetes and containerized environments, I feel that Kubernetes is expected to be integrating with other services such as DCOS. And what DCOS has done is they've actually layered upon Apache Mesos. And Apache Mesos is able to aid in creating a robust environment. Before going any further, I would actually like to go through this quick YouTube video with you regarding Apache Mesos. Actually, I'll keep this slow.
Hi, this is Aaron Williams, and I'm excited to introduce you to a new open source project called DCOS, the Data Center Operating System. DCOS is a new category of operating system that spans all of the servers in any data center or cloud and makes them behave like one big computer. This makes DCOS simply the easiest way to run containers in any production environment, either on-prem or in any cloud. In less than 10 minutes, you can install DCOS, add your favorite services like Spark or Cassandra with a single click, and then deploy and scale your containerized applications. In this video, I'll show you just how easy it is. The DCOS community has made installation super simple with dozens of templates and tutorials for the most common cloud and on-prem configurations. Once you have installed DCOS, you'll see the Data Center dashboard, which shows all of the resources DCOS is managing and the health of each component. In this case, we're starting with an empty data center, just waiting for some work. The first thing you'll want to do is install the services your app depends on. For that, we use the Universe, which is the open app store for your data center. Simply click Universe on the left side menu, and you see all of the services available to add to your DCOS. Let's first install Spark, which is a very popular open-source big data processing engine. Clicking Install Package will download and install Spark on your DCOS. That's it. No need to specify where to run it or how. DCOS does all the hard work of making it available. Next, let's install Jenkins in the same way for continuous integration. One-click installations with Universe means there's no time wasted fighting to set up new services, and you can feel comfortable installing, trying, and uninstalling as many services as you like. And the Universe is open, like all of DCOS. Already, the Universe contains dozens of very cool packages built for DCOS and submitted by the community. DCOS not only has a beautiful GUI, it also comes with a powerful command line, or CLI. For example, we can use the DCOS package install command to install another service, Kafka, which is a distributed messaging system often used in real-time big data and IoT applications. Whenever you install a DCOS service like Kafka, you also get new subcommands added to the CLI. For example, now that I've installed Kafka, I can type DCOS Kafka to interact directly with the Kafka service for doing things like adding and starting Kafka brokers. Now, with all the excitement around Docker and containers, let's look at how to run a containerized web server on DCOS. To run the container on a single machine, we might use a Docker command like this. But, using the DCOS GUI, I can run that same container far more reliably and at much larger scale in a full production data center. Let's see how it's done. In the Marathon interface, you can see all three services that we started are running and not consuming any resources yet. Marathon is the fourth service on that list and the only one we didn't explicitly launch because it comes pre-installed with DCOS. Marathon is a battle-tested, long-running job scheduler, like an ID for your data center. We can see it is already running apps for each of the services we installed. Let's click on the Create Application button inside Marathon and launch our web server application inside a container. Marathon is highly configurable, but most containers can be launched with just a few parameters. First, we'll specify an ID and a Docker image. Then we'll set the network to bridge and tell Marathon to let our container listen on port 80. Finally, we'll give it access to the public agent. Clicking on JSON mode, we can see the detailed configuration file that DCOS generates for Marathon, which we can save and reuse. Those of you familiar with the Docker run command will see the similarities and will understand immediately why it is so easy to start using DCOS with Docker. To start our web server, we click Create Application. Back in Marathon, we can see the containerized web server is now running. We can use the command line to see how easy it is to scale our app up. Imagine we start seeing more traffic on our web server. We're going to need more containers running simultaneously. Marathon makes it easy to scale our application by adding more containers. To do this, we use the DCOS Marathon command, tell it which app to update, and how many container instances we want running at once. Let's go with 20. In the GUI, we can see Marathon deploying those additional containers and automatically optimizing the placement of them across the data center. If we click on the web server app, we can see the details for each of the 20 containers. Now, switching back to the main dashboard, we can see our data center is hard at work. In less than 10 minutes, we've installed our services, launched our application, and scaled it up. Thanks for joining me for this introduction. I encourage you to visit dcos.io/install to get your data center running on DCOS today. And on behalf of the more than 50 companies who came together to launch the project and are committed to its adoption, I want to invite you to come join us. DCOS isn't just a great solution, it's a community. And we look forward to your feedback, input, and contributions.
So that was a pretty neat video. The only pitfall I see is the fact that they didn't mention that this is actually a privatized environment, meaning it's not open to the general public. It's only available to large businesses and corporate-based environments. So getting back to the presentation here, some future research I'm really interested in is in terms of the Hadoop's distributed file system in relation to DCOS and how efficient it is at obtaining the streaming of data, whether it be video, audio, and different stuff like that. And the reason for that is because it's distributed across multiple clusters and containers. And so I think there might possibly be some latency involved, as well as depending on the connection to the provider is another important thing to keep in mind. Also, Hadoop's distributed file system is really quite useful in data analytics context, because many data analytics in terms of the businesses love to look at the different data that's coming in. Especially Amazon is really big into this as well. Some other research would be into the complexity of the cloud providers and what's the maximum amount of features and functionality they can add to their cloud-based environment without losing the efficiency in terms of metrics. On top of that, I would also like to explore the security implications of adding all these layers and features, and if there's actually a maximum amount of features and so forth that can be added without compromising the security of that system that's in place. Finally, I would actually like to really see which is the top dog or the top performing cloud-based platform. So I find that DevOps is really great and providing this movement towards creating communication between IT and application developers. So the use of Kubernetes can be really beneficial to these individuals and make their jobs much easier without having to worry about HTML coding and all this other stuff, because they can really create a quick architecture either through Docker containers or G-Cloud based solution for allowing you to run Kubernetes with WordPress without having to worry about it going down or having some downtime. So overall, I think it's a very promising feature that can be used in the future and is still growing to this day. And I can really see many more features and functionality being added on to cloud providers through the use of Kubernetes and other tools that are similar to Kubernetes. Thank you.